All right, let's begin. So for this week's assignment, we had to update our collisions to do proper Bsphere to Bsphere, as well as create a visualizer tool and a math tool. So as you see here, we have different scaled frigates to showcase how the Bsphere visualizer can handle multiple scales. If I were to head over here and then just rotate in, we see I'm colliding with frigate 2. If I walk in and go a bit further, we can see that I'm colliding with both frigates 2 and 4. If I go a bit further, we're just colliding with frigate 4. And if I move this way, we can see that I am colliding now with the axis. If I were to swap scenes, even though we were still colliding with the axis, they are not in this scene, so we do not get any data from that until we swap back, and then we can start colliding with our frigates and our axes once more. No leaks. So for the visualizer, it is set up as a singleton. Whenever we collide, we set our toggle to true, and then we set it to either be a green or red Bsphere, and we pass in our Bsphere. I'll explain the Bsphere more with the collision. For the visualizer, though, when we call this visualize Bsphere, we push it onto a command queue where we pass in the object and the color, or specifically the Bsphere. In the game CPP, whenever it is time to draw through an attorney, we call the visualizer's visualize function. And this visualize will go through our command queue, get the center and radii of the Bsphere, compute the world matrix, pass it into our wireframe sphere, which we have just one of. We have one wireframe constant color Bsphere. And when we compute that, we get set the world, set the color, render it, pop off the command, and move on to the next one. And then the colors I took from 370. For the collidable, we now have a set collider model and update collision data. Since we don't have any low poly models, we just use the same graphics objects model. Updating the collision data allows us to make sure that the collidable model is keeping track of the model we see in the game. So in the case of our Bsphere, that just means getting the center and radii of our current Bsphere, updating the matrix by multiplying it by what we pass through, and then updating the radii by any of the rows. I chose the X row and getting the mag of it. Since we're assuming uniform scaling, we only have to check one row, and then by multiplying that, we can scale our radii properly. For both collision self and collision pair, it now calls the proper intersection within our Bsphere class, which quickly showing off, it is only const refs here. So when we do our intersection, we call our math function to do the collision. We get the center and radii of both Bspheres, compute the vector between them, add the two radii together, and if the dot product of our new vector is less than the square of the added radii, then that means we have collision. And then I also added math tools for getting the projection and perpendicular of any two given vectors. Within the tank game, we now have bullets destroying tanks. So whenever a tank is hit, it gets destroyed for a few seconds before being respawned. And then if I quickly go into here, we can see the purple tank. If it shoots the blue tank, it will try and pathfind to where it last saw the blue tank. And then when the blue tank respawns, it will start pathfinding properly again. For coding, the main thing I had to do this week in the demo was adding a strategy pattern for both the tank collisions and the bullet collision. This is because I was running into issues where the bullets and tanks would be colliding with multiple things in the same frame. So for our do collision call, I have two things: either update the collision data or just don't do anything. When we update the collision data for the tank, it says that we collided, so don't collide anymore. Confirm a kill and confirm a death, because I'm storing those as variables for points. And then we also call a revive. So for reviving, it uses another strategy to make sure we don't double register the alarm. So once again, the don't is do nothing. And then in the do, we update the alarm. So we set it here, and then we say we don't want to set another alarm. When it is time to actually revive the tank from setting after the alarm goes off, we will reinitialize the tank. And that's it.